Imagine we have an ordinary towel put on the surface, and alongside that we have a bowl of ink. And we put a spoonful of ink on the surface. There's our spoon. Spoonful of ink on the surface leaves a stain. Another spoonful, another. At the end, we have a good record of all we've done to the surface. If we wanted to use that, we would have to come along with what we call a processor, an outside processor, which would measure or relate the information. Now, that's the traditional way we think of the mind. Memory, thinking, traditional view of a computer, storage, processing. But let's contrast that with another system. In this other system, our surface is not a towel. The surface is a shallow dish of gelatine, or what we call jelly, what the Americans call jello. Looked at from the side, there it is. This time we'll heat up our bowl of ink on a little fire. When we put a spoonful of hot ink on the surface, while it's hot, it dissolves the gelatin, and when we pour away the dissolved gelatin and cooled ink, we're left with a little dip, a little depression in the surface. That corresponds to the ink stain. We repeat, 2, 3, 4. But this time we get something very different. We get a channel like that, sculpted in the surface or carved in the surface of the gelatine. What has happened is that if our second input is near the first, the wetness spreads, it flows into there, makes that deeper, that stays quite shallow. And similarly with the next one. So in the end, we get this channel. In other words, the input has been linked up. So what essentially we've got is that the gelatine has provided an opportunity for the incoming information to organize itself, that's the key word, to organize itself to give a pattern. And what do we mean by a pattern? It means that when we start somewhere, we're taken along to somewhere else. So if we started here, we would move along and end up there. Quite different from this system, where if we started there, we just stay there. Now, there's various other ways of showing it and how the nerves work in the brain, but essentially what we're looking at is a system, an active information system, quite different from computers and all other systems we use. And what it does, it allows incoming information to organize itself into a pattern, which is what we talked about when we said crossing the road, the mind has put together all the information to give a pattern so you recognize motor cars and so on. So what we're going to do now is have a look at patterns and how we use patterns. Before that, let's do two things. Let me ask Dinah to collect the Rubik's Cube, which I think has been done. Well done. Dinah, can we collect that? Well done. Well done. So that's very experienced use of patterns. Now, let me ask a question. What do you think the purpose of thinking is, in general? Anyone? Any suggestions? What do you think the purpose of thinking is?
Essentially to make sense of the world that we live in.
To make sense of the world we live in. Okay, some other suggestions?
For survival.
For survival. All right, I'll tell you what the purpose of thinking is. The purpose of thinking is to abolish thinking. In other words, the reason we think is really to find the nearest pattern and lock into it, and then we don't need to think anymore, we just follow the pattern. Let's move on to another exercise in pattern recognition. And what I've got here are some shapes which I'm going to put up out of focus. I'm going to put these up out of focus. And I want you, when you think you can recognize the shape, I want you to say immediately what you think it is. When you think you can recognize it. I'm going to come down slowly. When you think you can recognize it, say immediately what you think it is. Any offers? Any offers?
Tree.
Tree.
Two rabbits.
Tree with two rabbits. Absolutely correct. Good. So as soon as you recognize the pattern, you snap into it and you're away. Let's have another one. As soon as you recognize it, call out as you did before. I'm going to come down slowly. Any offers? Anyone?
It's the man.
What's he doing?
Looking at the fence.
Leaning on the time.
What's he doing?
Leaning over Drinking a pint of beer.
Drinking a pint of beer. So we're looking at patterns and how quickly we can recognize patterns. So recognition is one of the use of patterns, but of course sometimes it can go wrong. So we're going to look at a situation where it's difficult to tell which pattern we should be using. Dinah, let's have a look at the spool. And what we've got here is a spool with a cord wrapped around it, and Dinah's going to lay it out for us. Okay, and now she's going to roll it partly back till it's halfway along. And then I'm going to ask you, let's leave it there. Three things can happen when she pulls on the cord. It either comes towards me, away from Dinah, or it stays exactly where it is and spins, or it rolls itself up and goes towards Dinah. How many people, hands up, think when she pulls on the string, it will unroll and come towards me? All right? How many think it will spin and stay where it is? How many people will think that it will actually roll itself up? Okay, Dinah, you go ahead and pull. It rolls itself up. So there, when we're using the unrolling pattern, we're actually using the wrong pattern for that situation. Let's look at another one of these. Someone wants to give as a present a rather nicely carved block of wood, which is made of two different sorts of wood. And the two different sorts of wood are dovetailed together with a dovetail joint. The bottom wood is a dark one, the top wood is a rather lighter one. Now, the question I'm going to ask you is, would it be possible to make that sort of block with the two dovetailed together? Looks just the same from each side. And if he did make it, would it be possible to separate those two blocks? Let's have some suggestions. Those who think it would be possible to make it, first, would it be possible to make the proper dovetail joint thing? Those who think it would not be possible. All right? Those who aren't thinking. All right. So it seems impossible. So let's ask Diana to show us the impossible block. There we have the block. Now let's see if it can be, it looks the same from each side, proper dovetail joints. Let's see what happens if you try and undo it, Diana. Well, we see that it slides off very easily. Now what has happened, there we are, that's how it works. What has happened is this, that the pattern we normally use is we expect the joints to go like that because that's the normal pattern. But in fact, as we see there, the dovetail joint lines go like that, and we just slide one off the other very easily. So one of the difficulties with using patterns is if we get to use the wrong pattern, then we're in trouble. So let's move on from that, and we're going to look at something else to do with patterns. We looked at recognition, now we're going to look at abstraction. I'm going to put some shapes up here, and I'm going to ask you to tell me what they have in common. Some pattern we can abstract from them that they have in common. Let's have some suggestions. Just put up your hand and I'll know where to go. Let's have the lady in the middle of over there.
They're all made a straight line.
They're all made a straight line. Something else they have in common. Gentleman in the middle over here.
They could all be made out of squares.
They could all make out of squares, in fact 5 squares in each case, I think. All right, anything else? Anything else?
They've all got right angles in them.
They've all got right angles. All right, they essentially got right angles. They could all be made out of 5 squares. They could also be letters of the alphabet. That's a rather large I admit. So when we're looking at patterns, we often have to say, in this situation, what pattern can I take out? What pattern can I abstract from the situation? So when we're using patterns, we use them for recognition. We pick them out of situations. We abstract